Okay, the next step that we have to understand is how we can iterate through the list. If you remember, in arrays we can go through a loop, right, where the starting point is 0 and the ending point of my array is the array length, and then we just incremented our iterator one by one. So this was a one way of iterating in the array. But if you look at the list, there are no indexes, so these are objects randomly placed in random locations, and they are connected together just by an address reference. So we cannot have something called the length because we don't know how many nodes the list has, so it is really difficult when the size is not fixed. However, if you look at this list, this is a very simple list where we have only connections from 10 to 20, 20 to 30, 30 to 40, and 40 to null. So it goes in one direction. 10 can go to 20, however 20 cannot go to 10 because 20 doesn't know where is 10, but it can go to 30 because it knows where 30 is. So only one approach. So how we can actually iterate through this list and do something like printing or counting or adding the elements that are present in the list. So we have to make sure we understand the list. Okay, so if you look in the list, we already know from where the list begins, which is 10, and this address of the node containing the 10 value is given in the head variable, right? So we know the starting point of my list will be head. Whatever the ending, I have the node 10, I have node with value 20, I have node with value 30, I have a node with value 40, and lastly I have something called null. So the ending point of this list is basically is null. So this is something that gives me an idea about how to write the loop, right? The starting point will be head and the ending point will be null. And how the list is actually changing the values. So for example, I first have the address of 10 and I go to the address and print the content of the object. Then I have go to the next node object, right? And where it is written, this is written in my next variable, right? So basically in every iteration, what I have to do, I have to go to the next variable of my current object to set us the next iterator value. Okay, so per iteration we need to replace the addresses of the node. So if you look to this loop, if you say this, here I have node n which is equals to head, then I have a very simple while loop where I have the ending condition which is n not equals to null. So I'm going to iterate the list and changing the value of n till I get a null value. Okay, and how I change is by using n equals to n dot next. So the address that is present in my n node will be replaced. That means n will be this one in my next iterator, and so on. It will continue by changing the addresses that is contained in my object next variable. Okay, so this is how the loop can be written. I have shown you in the while form. Let's take a look to the for version. Same approach, we have the head as initial point, null as the ending point, and per iteration I change the address that is contained in my object node. Okay, now we are going to see some very easy functions, what we can do using this kind of list. Okay, so if you look at this list, how many nodes are there? Easy question, right? So we count the nodes, it's 4, right? But for programming languages, this is not easy. The list can be like 100 items and it need to go through all of them in counting. In array is very simple to define, to get the value of how many elements are in the array. Just we have to put array.length. It gives me the size of the array, right? But for linked list, I have to go through each of the objects and counting them, right? So how we can do it? Uh, if you look at this sample method which says public int count node, and it takes a reference of the head of of the list, and it will return some integer value. So basically it's gonna return the number of nodes that are present in the list. How we can do it? Okay, one thing to remember, the list, when you do work with the list, having the head node means you have the entire list, because as it has a sequential access, you can go through node to node to get the whole list. So you don't need any other parameter to have it. So with node reference, it will be fine to have the entire list. Okay, so how we can do it? So basically we're going to have a counter variable which is set to 0. Then we go through the entire list using the loop that we have learned in our previous slide. Here we have set it as a head n not equals to null and changing the address using n.next. Whenever the loop is iterating, I incremented the value of the count. So whatever is the value of count, it's gonna return here after iterating through the whole list. So basically, if we take an example of this list, the output should be 4. Okay, so here's how we can do the count function. Very simple, just you have to go through the list traversing. Now we are going to see the get function. So the purpose of the get function is basically, given a list and an index, it will return the element that is contained in the node that is given in the index. So here in this function we are passing as a parameter node head, basically is referring to the list, starting of the list, and we are passing an index value, and it's going to return an object which is basically the value or the element that is inside my node. As we know, the list does not have any valid indexes, but what we are use are some kind of imaginary indexes. Here we are taking 10 as in index 0, 20 is in index 1, 30 is in index 2, and 40 is in index 3. So for solving this function, we have to use again the counter variable like we did in our count function. So here I take C as a particularly temporary variable which will be used for counting the nodes, and I'm going to incrementing every time the node get changes, and I have to go through the list. So we have to use this for loop here which start with an head, and it's go iterating till it's found the null node. What I have to do is look if my counter got to the index. So if the counter and the index value is the same, it's going to return the value that is inside the node, which is reside in the element field. So it will return n.element. If the index is valid, in that case it will return -1. Let's see some sample input and output. So if my sample input is get head comma 2, as 2 is a valid index in the sample list that is given here. So if I count 10 with 0, 20 with 1 and 30 with 2, the output will be the value of the index 2, which is 30. If my input is something like get head comma 10, where 10 is an invalid index, so my output will be -1. Okay, the next function is basically the same. We have the same get function. However, this get function is known as the node add function. Here is basically I am showing the same concept that we have used for getting the value. I can use for getting the node address. This will be very useful when we do some more advanced function where we will need actually the address of the object where the value residing at, so we can use this node as function. Okay, so here if you look at the node add function, we have head, size and index. So head is basically referring the starting of the list. Size is actually the number of elements that are in the list, that is the number of nodes, and index is an index value or position of the node. And what we want to have from this function is the address of that particular node which index is given here. So how we can do it? The first step is basically checking the indexes. If the index is negative or is greater or equals to size, that means this is the invalid node and it's gonna return null. Otherwise, what we have to do, we have to go iterating through the nodes, and also as we don't have indexes, we will need a counter, right? Or what we can do is just simply write this loop. This loop is basically going through a counter starting from the 0 and going to till the index and incrementing one by one. As it increments the value of I, it also changes the address of the nodes. This is a loop that goes through index because we have already if here, which actually checks for a validity of the index. So we can use this loop here. Whenever it goes to the index node, it will gonna return the node n, which is basically the address. Okay. So if we have some input sample output, so if the sample input is get or node at head comma 4 comma 2, we're getting the address as an output of the node 30 because 30 is at index 2. If we have something like node at head comma 4 comma 10, so 10 is not a valid index, so it gonna return me as output as null. 0 is the index for the node containing 10, 1 is the index node containing 20, and 2 will be the index containing 30, which will be replaced with 50 instead of 30. And the last node that we have is 40, which will not be altered. Okay, so that's how the set function works. Okay, the last function that I'm going to show you is search, and we have basically an method called index of. Index of method will take as a parameter the starting of the list and an element, and going to return the index of that particular element. Okay, so basically it's going to return an integer. So how we can do it? So similar approach, we travel through the node where I am incrementing the index value one by one and checking it if the element is there. If the element is not there, it's going to return -1. So here I checked n dot element dot equals element, and if this is equal, I'm gonna return I, which contains the particular index that I'm looking for. So here are some sample input and output. If the sample input is index of head comma 50, the value 50 is not present in my list, so the output will be -1. And in the next sample we have index of head 40. 40 is present in my list, which is in my position 4, and the index will be 3 because it's starting with the 0 index. Okay, so that's all about the basic manipulation of linked list. Thank you.